So in forced oscillation, so there is an external force that is basically driving your oscillator or damped oscillator. So it means that force, whatever you are delivering, that force itself is oscillating in nature. So whatever will be the oscillation frequency of your oscillator, that will be same as the frequency of oscillation of your driving force. So if you remember yesterday that discussion, so that last whatever we have discussed, that was del square x by del t square plus twice beta del x by del t plus omega naught square x, that was f naught into sine of pt, right? F naught sine of pt, where p is the frequency, a driving frequency. So driving frequency means that external force, whatever you are applying, that itself is oscillating in nature, and the frequency of this force is small p. Okay. So now assume the general solution of equation, let us give that equation number 1 of equation 1 is x equals to a sine of pt minus theta. So I have assumed that the solution of this equation number 1, that is x equals to a sine pt minus theta. Now if you substitute this in this equation, in first equation, then what will get? So if you go do del square x by del t square, obviously you will get minus t square a. Okay, and del x by del t, if you differentiate with respect to time, you will get pa cos pt minus theta. When you differentiate, double differentiate with respect to time, that will provide you minus p square a sine pt minus theta. So I'll use this. So in place of del square x by del t square, I'll substitute minus p square a sine of pt minus theta. Okay. In place of dx by dt, I'll substitute pa cos of pt minus theta. Okay. And you have last term, that is omega naught square x is your a sine pt minus theta. Okay. And look at that right hand side term. So you have f naught. Okay. Now I'll use, look at this thing. In place of pt, I can write pt minus theta plus theta, right? In place of pt, I can write pt minus theta plus theta. Okay, that's not a problem. Now I'll assume pt minus theta, that will be a, and that will be b. So sine a plus b. Okay. So if I use sine a plus b, I'll get f naught sine pt minus theta cos theta, then f naught cos of pt minus theta, and you have sine theta. Is this part clear to all? Is this part clear to all?
Yes, sir.
Okay. Now I'll compare, sorry. Now I'll compare the coefficient of sine pt minus theta of left hand side and right hand side. So you can see sine pt minus theta is here, and you have sine pt minus theta. So its coefficient is how much? Minus p square a, and there you have omega naught square a. And on the right hand side, you have only f naught. So what I can write? I can write, if I compare the coefficient of sine pt minus theta of both sides, I can write omega naught square minus p square into a. That should be equals to how much? f naught cos theta. I can write. So this is your equation number 2. And if similarly, if you compare the coefficient of cos pt minus theta, so you have cos pt minus theta here, and on the left hand side only this term contains cos pt minus theta, and its coefficient is twice beta pa, and the coefficient of cos pt minus theta on the right hand side is f naught sin theta. So if I can clearly write twice beta p into a, that should be equals to f naught sin theta. And let us assume this is your equation number 3. Okay, now can I calculate the amplitude? Now can I calculate the amplitude from equation number 2 and 3? How can I calculate amplitude? How can I calculate amplitude? Anyone? कैसे calculate करोगे amplitude? If you square equation numbers 2 and 3 and add, then what you will get? On the right hand side you will get only f naught square, and on the left hand side you will get omega naught square minus p square whole square plus 4 beta square p square into a square equals to f naught square. So from there you can calculate the amplitude, because a is nothing but amplitude of oscillation, right? A is nothing but amplitude of oscillation. So I can calculate that amplitude of oscillation. Okay. So have you written this part up to this?
Sir.
Okay, shall I erase?
Yes, sir. Yes, sir.
असाइनमेंट किए हो आप लोगों ने सारे?
Yes, sir.
Okay. So few people already sent. Tomorrow, today I'll check and I'll let you know. Okay. Okay. So if you square equation number 2 and 3 and then finally add, then left hand side will provide you omega naught square minus p square whole square plus 4 beta square p square into a square, right? That is all about your left hand side. And right hand side, that will provide you f naught square into cos square theta plus sin square theta. So it means it will be simply f naught square, because cos square theta plus sin square theta, that will provide you on, right? Okay. So it means I can write the amplitude will be simply f naught divided by square root of omega naught square minus p square whole square plus 4 beta square p square. What I have done? Just I have taken square root both sides. So if you take square root both sides, so this term will become a square root of this itself. A square will become a, and f naught square will become simply f naught. So now if you rearrange, you will get amplitude of oscillation, that will be f naught divided by omega naught square sorry, minus p square whole square plus 4 beta square p square. So this is all about your amplitude of oscillation under forced oscillation. Is this part clear to all? So finally I can write the solution of your post oscillation can be written as f naught divided by square root of omega naught square minus p square whole square plus 4 beta square p square, and you have sine pt minus theta. What I have done, just I have substituted value of amplitude, because you assume that the solution of your equation, that was a sine pt minus theta, and you obtained that value of a amplitude, right? And that amplitude itself depends upon what factor? It depends upon natural frequency of oscillation, driving frequency, right? These are the main term that actually in that two terms your that amplitude of oscillation depends. Okay. Now I'll look at different possibility. What will be the amplitude of oscillation when the driving frequency is low? What will be the amplitude of oscillation when driving frequency is high? Okay. So first case, I look when driving frequency P is much smaller than natural frequency of oscillation. So in that scenario, what will be the amplitude of oscillation? So this is your amplitude of oscillation, right? When P is very small, so I can ignore P square from this term itself, right? So when P is small, what I can write? A will be F naught divided by, if P is much smaller as compared to this term, let us assume P is of the order of 10 to the power minus 7 and omega is of the order of 10 to the power cube. So I can clearly neglect this term. It will not affect anything. So in that scenario, I can write omega naught square plus 4 beta square P square, right? Not omega naught square, it will become omega to the power 4 because omega square whole square, that will be omega to the power 4. Now if I take omega to the power 4 common, so it will become f naught divided by omega square root of 1 plus 4 beta square P square divided by omega to the power 4. Okay. Now this term will be 0 because omega is very high as compared to P, and damping itself, that will not be omega, actually it will become omega naught, right? It will be omega naught. And of course that in natural case, omega naught is much large as compared to beta. And also that the case that you have assumed, that is driving frequency is smaller as compared to omega naught. So what I'm trying to say, this term will be 0. So in that scenario, your amplitude of oscillation will become f naught by omega naught square. Okay. And you know what is f naught? F naught was nothing but capital F naught by mass divided by omega naught is nothing but k by m, right? So m will be gone. So simply you will get f naught divided by k. F naught divided by k. So under low driving frequency, the amplitude of oscillation is equals to f naught by k, right? So we can say that under low driving frequency, the amplitude of oscillation only depends upon spring constant, but it is independent upon your driving frequency. Okay, you can clearly check from this equation itself that amplitude of oscillation only depends upon, this is your force amplitude and k is spring constant. So it is independent upon driving frequency, but of course it is depends upon the spring constant. Is it clear?
Yes, sir.
Okay. Now case number 2. आप लोग कैसे पढ़ाई कर रहे हो? कॉन्फिडेंस आ रहा है आप लोगों को?
Yes, sir. Yes, sir.
Yes, sir.
ओके. आर यू एंजॉयिंग क्लास? क्लास में सब कुछ समझ में आ रहा है आप लोगों को?
Yes, sir.
Okay, good. Okay, now we'll discuss that case when the driving frequency P is much greater than omega naught. So what will be the case scenario now? Now in that scenario, what will be the amplitude? How it depends upon that parameters. So in that case, if you remember that amplitude was how much? It was f naught divided by square root of omega naught square minus p square plus 4 beta square p square, right? This was your amplitude. Now in that scenario, you can neglect, and of course there is a square here. In that scenario, you can neglect your omega naught square because this is so small as compared to driving frequency. So I can write, or modified a form of amplitude will simply become f naught divided by square root of p की power 4 because I have neglected omega naught and you have minus p square whole square. So obviously it will become p की power 4. And this the second term you have, that is 4 beta square p square, right? Now I'll take p की power 4, that I'll take common. So if you bring that p की power 4 outside of square root, so it will simply become p square, right? And you have 1 plus 4 beta square divided by p square, right? Now since driving frequency is large, very large, so obviously this term will become 0 in that scenario. So I can write amplitude of oscillation equals to f naught by p square. And you know what is f naught? That is capital F naught by m, and you have p square. Now you can check that when your driving frequency is so large as compared to natural frequency of oscillation, in that scenario, the amplitude of oscillation is no longer depends upon spring constant, but it is clearly noticeable that it depends upon driving frequency. Okay, it is clearly noticeable that amplitude of oscillation, it depends upon driving frequency. Okay, now that question arises, and this is really important for your exam purpose. At what value of p, the amplitude will be maximum. Amplitude will be maximum. How will calculate this part? So at what p the amplitude of oscillation will become maximum. So this is your formula of amplitude, right? F naught divided by this. So when that amplitude will be maximum, when this part will be minimum, right? Because this is in denominator, so when that denominator part is minimum, of course A will become maximum. And how will calculate that minimum and maximum condition? That you know that part. Just you have to differentiate with respect to P and you have to equate with 0. And that will provide the value of P. In that value, you will have a minimum of this value. It means at this scenario, amplitude will become maximum. So to calculate that P at which amplitude maximum, you have to differentiate with respect to P of this term, omega naught square minus P square whole square plus 4 beta square P square. That you have to calculate and you have to equate with 0, because this is the condition of maxima or minima, right? So just differentiate with respect to P and substitute equals to 0 and calculate the value of P. So this kind of question you see from post oscillation, they will ask you this kind of question. Okay, so there will be very less problem from this part for your exam, but the question will be arising like this: at what value of P you will have maximum amplitude. So if you calculate this, if you differentiate this part, how much you will get? Minus 4p, then you will have omega naught square minus P square plus 8 beta square P, and that should be equals to 0. Now if you take P common, 4p common, then what will you get? Minus omega naught square plus P square, and you will have, right? You have 2 beta square, right? And that should be equals to 0. So it means you will have two conditions, either P equals to 0 or P equals to square root of, right? So multiplication of two terms 0 means either this term is 0 or this term is 0. So if you equate this equals to 0, of course P will be 0 because 4 is never 0. And if you equate this term equals to 0, that will provide you what? omega naught square minus 2 beta square, right? Is this part clear what I'm trying to say, everyone?
Yes, sir.
Okay. So you have two conditions. Now, if you further differentiate with respect to p and substitute that p equals to 0, that will give you maximum of this function. I mean, at p equals to 0, maximum minimum कैसे चेक करते हो आप? डबल डिफरेंशिएशन से पता चलता है ना आपका कि मैक्सिमम whether it is showing maximum or minimum, right? If you differentiate, yes. Now you
Yes, sir.
calculate at what value of p you will have maximum, you have maxima or minima. अगर इसको डबल डिफरेंशिएट करोगे एंड इस ये पॉइंट ये p का वैल्यू ये सब्स्टिट्यूट करोगे तो इस पॉइंट में क्या आएगा, तो वो फंक्शन नेगेटिव आएगा. डबल डिफरेंशिएशन का वैल्यू नेगेटिव आएगा, मतलब एट p इक्वल्स टू 0 this function will have maximum value. If you substitute p equals to this after double differentiation, that will give you positive number. It means at p equals to this value, you will have this function will be minima, right? So it means amplitude will be maximum when you will have driving frequency that will be equals to square root of omega naught square minus 2 beta square. Okay, now can you able to solve? Can you? So you have this is the condition. Okay, did you get this part or I have to repeat? Did you get this part or I have to repeat? Everyone?
So ये p equal
Calculate
to
कर
root of omega square minus 2 beta इसमें
हाँ.
minimum आता है ना?
हाँ, अच्छा ये वाला कैसे आया आपको समझ में आया? Did you get how we have obtained this part?
Yes sir, yes sir.
Okay, you obtained, you got, right? Okay. Now whatever you are saying, that is correct. At this p, you will get minimum value of this function. How will check? This is your homework. Just you differentiate again this function with respect to p. I mean double differentiation. After double differentiation, excuse me. After double differentiation, you substitute this point p equals to 0 and p equals to root over omega naught square minus 2 beta square. When you will substitute p equals to 0, you will get minus value. What does it mean? At p equals to 0, this function will have maximum value. When you will substitute p equals to square root of omega naught square minus 2 beta square, at this point or at this value of p, the double differentiation of this function will have positive value. It means at p equals to this value, this function will have minimum value. What does it mean? It means the amplitude will be maxima when driving frequency equals to omega naught square minus 2 beta square. Now I'll calculate that maximum amplitude. How will calculate? Just I'll substitute this value. So if you substitute it, you know A was how much? F naught divided by, okay, omega naught square minus p square. So if you substitute in place of p like this, you will get 4 beta ki power 4, right? And you have 4 beta square, and in place of p square I'll substitute omega square minus 2 beta square. Okay, so what I have done, in place of p, just I have substituted this in amplitude formula. So if you substitute, first term will give you 4 beta ki power 4, and second term you have 4 beta square p square. So in place of p square, I have substituted this value, that is omega naught square minus 2 beta square. Okay. Okay. Now if you rearrange further, then maximum amplitude will be how much? So you have f naught, right? And this will provide you square root of, you see 4 beta ki power 4, and from this term you will get minus 8 beta ki power 4, right? Minus 8 beta ki power 4. So it means you will have 4 beta square omega naught square minus 4 beta ki power 4. Okay, just if you separate this term, how much you will get? 4 beta square omega naught square minus 8 beta ki power 4, and you have 4 beta ki power 4 here. So it means it will give you 4 beta square omega naught square minus 4 beta ki power 4. Okay, now I'll take 4 beta square common. So it will then it will provide you 4 beta square common means it will give you 2 beta into square root of omega naught square minus beta square. क्या इतना सबको समझ में आया? किसको समझ में नहीं आया? Did you get this part, everyone?
Yes.
Yes, sir. समझ में आएगा. Yes, sir.
Yes,
Okay.
sir.
Okay, now can I write omega naught in place of omega naught square minus beta square? So from here, can I write omega naught square minus beta square equals to p square plus b square? Because p square is how much? Omega naught square minus 2 beta square, right? P square is nothing but omega naught square minus 2 beta square. It means omega naught square minus beta square will become how much? P square plus b square. So in place of omega naught square minus beta square, I'll substitute p square plus beta square. From here I can write, right? P square plus beta square, that will be how much? Omega naught square minus beta square. So I'll substitute this omega naught square minus beta square here. So I'll get f naught divided by 2 beta square root of p square plus beta square. Okay. Is this part clear to all? ये समझ में आया आप लोगों को?
Yes.
Yes, sir.
Okay. Okay, if it is clear to all, now you got your maximum
Yes, sir.
amplitude. You got your maximum amplitude, right? That is your A max. Okay. So you got your displacement. XT was how much? XT is A was how much? F naught divided by omega naught square minus p square whole square plus 4 beta square p square, and you have sine function, right? Sine of pt minus theta. This is all about your displacement. Okay, displacement of force oscillator. Now we'll calculate velocity of oscillators. How will calculate? How will calculate velocity?
Differentiation.
Exactly. So simple. So velocity as a function of time, it will become simply dx by dt, right? Okay, if you differentiate, so these all are independent on time, right? Everything. Only time dependent function, that is sine pt minus theta. So if you differentiate with respect to time, you will get f naught p cos of pt minus theta, right? And you will have this term omega naught square minus p square whole square plus 4 beta square p square, right? So this is your velocity of force oscillator. So you can clearly see the velocity is oscillating in nature, because cos pt minus theta, this function is oscillating in nature. So of course velocity will be oscillating in nature. Now I will assume that Vt equals to Va into cos Pt minus theta. So it look like Va is your maximum value, right? Maximum value of speed. So Va will be how much? Va will be simply f naught p divided by omega square root of omega naught square minus p square whole square plus 4 beta square p square. Okay. So I can write Va will be how much? Here will be simply f naught p divided by square root of omega naught square minus p square whole square plus 4 beta square p square, right? This is your VA, right? So this is your all about your
Yes,
VA.
sir.
Now so this is like a velocity amplitude, or you can say this is the maximum velocity of force oscillator. Because why? Because maximum value of cos pt minus theta can be +1, right? So this is the maximum value or velocity amplitude, you can say. Now I'll calculate or I'll approximate that velocity amplitude for different value of p. So similar to displacement, I'll first check case number 1, when p is much smaller than omega naught. When p is much smaller than omega naught, so what will be the velocity amplitude? Can you please check? Everyone, please check it. Yes. So of course, when omega p is much smaller, again I can ignore this p from here itself. Okay. So similar to displacement, whatever we have, or amplitude, whatever we have discussed for amplitude case, similar we'll obtain from here. Here it's also here itself I'll obtain. So in that scenario, I can clearly ignore this p, right? And this term also ignorable. So what I can write in that case, your VA will become how much?
F naught by omega.
F naught p will be there, right? F naught p divided by omega square will be there, because you see this is omega square whole square. Okay, so if you bring outside of square root, so this square will be gone, you will have omega square, right? Okay, so in that scenario I can write f naught is how much? Basically f naught is capital F naught by m, right? And you have omega naught square, that is k by m, and you have p also. So this m will be cancelled, you will get capital F naught p by k, right? So what is the difference between amplitude and amplitude of displacement and velocity amplitude? पहले क्या मिला था आप लोगों को बताओ, पहले वाले केस में what you have obtained, what is the difference? क्या difference मिल रहा है? So if you remember, when that driving frequency is very less, in that case the amplitude of displacement only depends upon spring constant, but the velocity amplitude, you can see it depends upon spring constant as well as driving frequency. Okay, so that is the difference. Now case number 2, when p is much greater than omega naught, so what will get? VA will be how much now in this case? VA will be how much? So in this case you can ignore what? Omega naught you can ignore, so only you will get p की power 4. So if you bring this p की power 4 outside of square root, so what I'm trying to say, यहाँ से आपका क्या ignore कर सकते हो आप? You can ignore omega naught, right? So you'll get p की power 4, and you have 4 beta square p square also. Now I'll bring p की power 4 outside of square root, so you'll have this term will become 1 plus 4 beta square divided by p square. So since p is large, second term I can ignore, 4 beta square by p square, that will be 0. So in that case you will get f naught p divided by p square, right? So it means it will be f naught by p, and you know what is f naught? F naught means capital F naught by m, right? And you have so when driving frequency is large, in that case that velocity amplitude is depends upon what? only driving frequency, independent on spring constant. So see this kind what I already said, from this topic they will ask this kind of question. So there is a very less problem from this topic itself, but there are many things inside this topic. So all is kind of derivation, but you have to be very careful because this kind of question they will ask you. When the driving frequency is very large, what will be the form of your velocity amplitude? So at what value of driving frequency you will have maximum amplitude of displacement? Kind of this question. Okay.
Yes, sir.
Is it clear? Now you already have calculated amplitude of displacement at what value of P the amplitude of displacement is maximum. Now the question is at what value of P the velocity amplitude will be maximum. So there are two cases, you know. Initial case was capital A. Capital A was how much? The displacement amplitude, right? VA is velocity amplitude. So previously we have calculated that at what value of P you will have displacement amplitude is maximum. Now my plan is to calculate at what value of driving frequency the velocity amplitude will be maximum. How will proceed? Any clue from your side?
Yes.
कैसे करोगे?
डबल डेरिवेटिव्स करेंगे.
डबल डेरिवेटिव वो तो पहले वाला था, है ना? वो आप लोग करके मेरे को सेंड करना प्लीज, ठीक है? अब लोग होमवर्क प्रॉपर्ली करो, है ना? जैसे आप लोगों को दिया जाएगा, प्लीज डू इट केयरफुली एंड सिंसियरली. दिस इज वेरी हेल्पफुल. क्यों दिया जाता है होमवर्क? क्योंकि आप कैलकुलेशन आप खुद करो, उसमें क्या होगा, आपका एक्यूरेसी लेवल बढ़ेगा, ठीक है? उसीलिए दिया जाता है, ठीक है? प्लीज डू इट एवरीवन.
Yes.
Okay. Now in that scenario I'll not go to differentiation because I have some logic, you know. So I'll do this. So I'll take P square outside of this. So VA will be how much now? F naught P. Now if I take P square outside of square root, so it will become, how it will look like? P divided by omega naught square minus P square whole square divided by P square plus 4 beta square. This will be form, right? So this will be your form of that velocity amplitude, right? Anyone has any problem in this part? Nothing I have done, just I have taken P square common outside of square root. Is it clear, everyone?
Yes, sir.
Yes, sir.
Okay. Now any clue how will proceed? At what value of P that your velocity amplitude will be maximum? So this P will be cancelled. कैसे करेंगे? How will do this? Please tell me. Rajkumar, Shekhar, Dhruvi, Anju, please tell me. धीरज, याचिका, कैसे करेंगे बताओ? अच्छा, इस फंक्शन को, ये वाला पार्ट को आपको मिनिमम होना पड़ेगा, राइट? दिस पार्ट शुड बी मिनिमम, राइट?
Yes.
This is some positive number. This is some 4 beta square. Beta is some damping parameter. It can be 0 or it can be some positive number, right? So this is positive number. Again, this part will be positive. देखो ये पार्ट पॉजिटिव है. अच्छा, समथिंग 4 बीटा स्क्वायर प्लस समथिंग. अब ये वाला पार्ट बताओ, ये डिनोमिनेटर कब आपका मिनिमम होगा? जब ये वाला पार्ट मिनिमम होगा. डिनोमिनेटर कब मिनिमम होगा? बिकॉज 4 बीटा स्क्वायर इज सेपरेट. नाउ लुक एट दिस पार्ट. व्हेन दिस पार्ट विल बी मिनिमम? बिकॉज दिस इज always be positive. Why? Because P square you will have some positive number. Omega naught square minus P square whole square, that will always be some positive number. That is no doubt, right? Is it clear what I'm trying to say?
Yes.
Omega naught square minus p square whole square, that will provide you some positive number, whatever value p and omega you are taking, and p square will also be positive number. Now इसको मिनिमम होने के लिए क्या होगा, ये तो आपका हम पॉजिटिव नंबर है, इस टर्म को मिनिमम होना पड़ेगा, ये तो आपका सेपरेट है, इसको आप कुछ नहीं कर सकते। इसको देखो, इसको मिनिमम वैल्यू कितना हो सकता है पॉजिटिव नंबर का, 0। मिनिमम कितना हो सकता है पॉजिटिव नंबर का, 0।
0।
हाँ, तो p इक्वल्स टू ओमेगा नॉट में देखो ये वैल्यू 0 हो रहा है, तो डिनोमिनेटर कब मिनिमम होगा, p इक्वल्स टू ओमेगा नॉट पे, बिकॉज दिस टर्म विल बी 0 नाउ। इज इट क्लियर व्हाट आई एम ट्राइंग टू से?
Yes,
Sir.
sir.
Clear everyone? Please respond me. What I'm trying to say, is it clear to all?
Yes, sir.
Yes, sir.
Yes,
Okay.
sir.
Okay. So it means VA will be maximum. It will be maximum when P equals to omega naught. Right? So VA maximum will become how much? So it will be F naught by twice beta, right? Because this term will be 0. This term will be 0, right? So velocity amplitude now becomes F naught by twice beta. Now we'll discuss little bit about power dissipation. So if it is clear, we should proceed for power dissipation. Is it clear to all?
Yes, sir.
Yes.
Okay. तो पावर डिसिपेशन किसके कारण हो सकता है बताओ? In force oscillation, power dissipation will be depends upon what factor? What is power dissipation actually? Let us denote this notation is capital P and D. So if you remember, in damped oscillator itself, we have discussed about that power dissipation. So here also, the damping force is the main reason of power dissipation, because there is no other source of power dissipation. Power dissipation means rate of energy loss, and you have three kind of parameters that may decide the power dissipation or absorption. So you have restoring force, damping force, and you have external oscillating force. So oscillating force will always provide you power absorption because you are giving force from outside. So that will provide you power absorption. And power dissipation is the main cause of damping force. So power dissipation can be written as PD equals to FD into V. ठीक है ना? पावर डिसिपेशन क्यों हो रहा है? क्योंकि डैम्पिंग फोर्स में क्यों होता है? क्योंकि in damping medium there will be always some friction between that molecules, and you have oscillator. That friction causes there is a loss of energy. So power dissipation, that damping force is the only source of power dissipation. So you know how power is to write, that is power is nothing but force into velocity, right? That you know everyone, right? Power is nothing but force into velocity, right?
Sir.
Okay, force into
Yes, sir.
velocity. So FD means damping force into velocity. Now how will calculate now? Anyone? So you know damping force is how much basically? B into V, right? So I'm not taking minus sign because I'll only deal with magnitude. So you know damping force is nothing but minus B into V. But for the time being, I'm ignoring minus sign because I'll take only magnitude value and I'll observe how much power dissipation is happening. So this is nothing but B into V square. And you know V, right? V is how much basically? So if you remember for your force oscillator, V was how much? So it was F naught P divided by square root of omega naught square minus P square whole square plus 4 beta square p square, right? That was your V, and you also have cos of pt minus theta. So since V square is there, so you have 2 square. So power dissipation is BV square, and we already have calculated for the expression of velocity. Just I have substituted that expression, that was F naught P cosine of Pt minus theta divided by square root of omega naught square minus P square whole square plus 4 beta square P square. Okay, is it clear? Is it clear to
Yes,
all?
sir.
Yes, sir.
Okay, if it is
Yes.
clear, can you please tell me what will be the average value of power dissipation? And I am asking about time average of power dissipation. How much it will be? So it will be how much? P, and you have F naught square P square divided by omega naught square minus P square whole square plus 4 beta square P square. Now if you remember, just 2 or 3 class back, I told you what is the average value of cos square theta? Yes, anyone? Do you remember?
1/2.
1/2, right? So when I am dealing with time average, so this cos square theta will become, because this is all are time independent, you know, these parameters all are time independent. So of course I have to take only time average of this cos square theta or cos square pt minus theta, and we know cos square theta, that time average will always give you 1/2. So you will get here 1/2. Is it clear? Is this part clear what
Yes,
I'm
sir.
trying to say? Okay.
Yes.
Now what will be small b in terms of damping parameter? What will be it is?
एक बार रिपीट फिर से कर दो
कौन सा? टाइम एवरेज? ओके, ये वाला पार्ट तो क्लियर है, जो आपका स्क्वायर ये कांस्टेंट वाला एफ नॉट स्क्वायर पी स्क्वायर देन यू हैव ओमेगा नॉट स्क्वायर माइनस पी स्क्वायर, दिस पार्ट इज क्लियर, राइट? यू हैव
यस सर
only time dependent part is what here? Cos square pt minus theta, right? Time dependent part is what actually? Cos
Yes.
square pt minus theta. Now what I'm trying to say is, when you are calculating time dependent or time average of power dissipation, so you have to take only time average of cos square pt minus theta. Now tell me what will be the time average of this function 0 to t cos square pt minus theta divided by 0 to t dt. How much it will be? cos square theta का टाइम एवरेज कितना होता है? cos square theta sin square theta का कितना होता है?
1/2.
1/2.
1/2 होता है हमेशा ना. It will always provide you 1/2. Whatever phase is there, please be noted that whatever phase inside, when you will deal with time average of cos square some phase, it will always provide you 1/2, no matter what phase inside of this. Okay, is it clear what I'm trying to say?
यस सर यस
Yes, sir.
Okay, so if it is clear, you can calculate also. What is your name? What are you asking?
यस सर
Dhiraj, right? Okay, so Dhiraj, please do it. This is your homework for yours. Please calculate it and share it. Okay, I'll check. You have to prove that for any value of theta, that time average will provide you 1/2. That you have to do, and you please do it and share me. I'll check. Okay. So this is your 1/2 b, and can I write in place of b? I can write twice beta into m, right? I can write it
Sir.
because I can write, right? Because we know that beta b by m was how much? Twice beta. So in place of small b, I can write twice beta into m. So I can cancel these two, right? I can cancel, so I'll get the time average of power dissipation, that will become beta into f naught square p square divided by omega naught square minus p square whole square plus 4 beta square p square. So this will be your time average of power dissipation. Now again the question arises, at what value of driving frequency that power distribution will be maximum? Yes. Now you can do it yourself. How will do it? So that P I am
Theta is
asking.
equal to P.
Okay, now you see, if you take P square common again, if you take P square common from denominator, then you can notice at P equals to omega naught, the denominator factor will be minimum, because again it will come like omega naught square minus P square divided by P square plus 4 beta square. So what I am trying to say, PD will become beta m f naught P square divided by, if you take P square common, it will be omega naught square minus P square whole square divided by P square plus 4 beta square. So similar to velocity amplitude, you can claim that at P equals to omega naught, this function will be minimum, right? So I can say at P equals to omega naught, you will have time average of power distribution will be maximum. So PD max will be how much? Beta m f naught square divided by how much? 4 beta square. So it means m f naught square divided by 4 beta. Is this part clear, everyone? Is this part clear? All?
Yes, sir.
Yes, sir.
Okay. What is the time? Okay. So we have few more parts. Tomorrow we'll discuss rest of the part. So if you people have any question, you can ask me. Do you have any question, anyone? Any question is there?
No, sir.
Okay. आप लोगों को समझ में आ रहा है चीजें?
Yes, sir.
Yes, sir.
Are you enjoying class?
Yes, sir.
Okay. Okay. Please do that homework. Okay, and share me. I'll check.
Yes, sir.
Okay. Okay. If you have no question, we should stop here.